Okay, this is lesson 5.2, and in lesson 5.2 we're going to work more with expanding. But this time when we expand, we're going to get answers that are special. And why are they special? Well, they're special because they've been named. There's three different types of special products, and they result from when you take a bracket and you square it. Whether the sign in the middle is a plus or a minus, it doesn't matter, but the result will come out as something called a perfect square trinomial. And I'm going to show you what that looks like. And the second one is where you take two brackets that look almost the same. The only difference is the sign is different. One's positive, one's negative. The result ends up being something called a difference of squares. So if we look at our examples, I'll show you what I'm talking about. Here's our 5 examples. In this one, we just have a single bracket being squared, and we did an example like this in 5.1, but I'm going to show you how it results in something called a perfect square trinomial. In this bracket, the sign in the middle is a plus. In this bracket, we have a single bracket being squared again, but the sign's a negative. It doesn't matter if the sign's positive or negative, the result is going to be a perfect square trinomial. Same with this one. It doesn't matter how complicated the bracket looks, if there's two terms and they're being squared, the result will be a perfect square trinomial. Now the last two will result in difference of squares. And the reason why is because, well, we have two brackets that look almost identical. The only difference is the signs. Same with this one. 5C and 4D, 5C and 4D, 1 plus, 1 minus. It doesn't matter if the plus comes first or the minus. This one, the minus came first. Either way, the result's going to be a difference of squares. So we're going to expand a bunch of these. I'm going to show you what I mean by perfect square trinomial and difference of squares, and then we're going to discuss how you could get to the answer a little bit quicker. So let's take a look. X plus 3 squared. If we were doing x plus 3 squared, we would just write the bracket twice. X plus 3 and x plus 3. And we wouldn't do anything different than we did in the last lesson. We would FOIL. X times x gives us x squared. X times 3 gives us 3x. 3 times x gives us 3x. 3 times 3 gives us 9. And now we have two like terms in the middle, 3x and 3x. If we put them together, we get 6x plus 9. All right, how is this a perfect square trinomial? Well, by definition, a perfect square trinomial follows a pattern. The pattern is a squared plus 2ab plus b squared. Well, what's a and b? A and b are whatever's in the original bracket being expanded. So I'm going to write this down underneath with a highlighter. So if the bracket is a plus b squared, then our answer will be a squared plus 2ab plus b squared. So let's take a look. Let's see if it follows the pattern. If a is x, then our answer has to be a squared. Well, that means our answer would have to be x squared, which it is. We're going to skip the middle term for a second and go to the last term. The last term is supposed to be b squared. Well, if b is 3, 3 squared is 9, it follows the pattern. Now the middle term has to be 2 times a times b. So let's see if we can do this. Remember, 2 times a is x, so 2 times x is 2x, times b, 2x times 3 is 6x. So it follows the pattern. What's the point of this? Well, right now, there's not really a point other than if you remember the pattern for perfect square trinomial, you don't have to FOIL. You can go to the end faster. Well, what do I mean? Well, what I mean is, if I have x minus 7 squared, we could recognize that as a perfect square trinomial. And we could write the bracket twice. And we could FOIL. And then we could collect like terms and we could get an answer. Or we could try to use the patterning to get to the answer faster. Well, let's try it. This one is a minus b. And if we look, it says that a minus b, if we square it, should give us a squared minus 2ab plus b squared. Slight difference because the signs in the middle are negative. So that means we should end up with a squared minus 2ab plus b squared. So let's see if we can skip the FOIL and go right to the answer. Well, if a is x, our first term is supposed to be a squared x squared. And our last term is supposed to be b squared. Well, b is 7. 7 squared is 49. And the middle term is supposed to be negative 2ab. Well, negative 2 times x is 2x minus negative 7 would give us negative 14x. So let's see if we got it right. We're going to FOIL this out. X times x gives us x squared. X times negative 7 gives us negative 7x. Negative 7x times x gives us negative 7x. And negative 7 times negative 7 gives us 49. And if we collect the like terms, negative 7 and negative 7, we do get negative 14x. So do we have to memorize these patterns and go right to the answer? Absolutely not. We can just FOIL every time. In fact, that's probably what I would recommend to you. I would recommend just FOILing it out. What is important, though, is being able to recognize this as a perfect square trinomial, because eventually in this unit we're going to do something called factoring, and factoring is going backwards. And it becomes really valuable if you can recognize this as a perfect square trinomial. But we'll do more on that in future lessons. So why is it a perfect square trinomial? Well, the reason why is because realistically, when you're FOILing, you're going to do an x times x. That's where the x squared comes from. You're going to do a 7 times 7. That's where the 49 comes from. The o and the I steps in the middle of FOIL are negative 7 times x. Negative 7 times x and x times negative 7. They're two of the same step. They're two of the same step. Two of the a times b steps. It's just in different order. Okay, I'm going to leave one FOILing for you. Actually, it's a little complicated. I'm going to do it with you. We won't use the patterning. We will just expand it. 2x plus 3y, 2x plus 3y. 2x times 2x. 2 times 2 is 4. X times x is x squared. 2x times 3y. 2 times 3 is 6. And what do we do when we have a letter times a letter? Well, we just put the letters together. X, y. 3y times 2x. 3 times 2 again is 6. X and y and x, we put the letters together. Usually write them in alphabetical order. X, y. And our last step, 3y times 3y, gives us 9y squared. And now we can put our like terms together. We got 4x squared plus 12xy plus 9y squared. And there we go. And if we've noticed, this is a perfect square trinomial again. Square the first term, we get 4x squared. Square the last term, we get 3y. So 3y times 3y is 9y squared. And the middle term is just 2 times 3, which is 6, times 2, gives us the 12. X times y gives you the xy. All right, that's it for perfect square trinomials. Let's try a differences square. Well, in a differences square, we have two brackets that look the same with different signs. I'm going to FOIL this one out and show you what happens. Y times y gives us y squared. Y times 12 gives us 12y. Negative 12 times y gives us negative 12y. Negative 12 times 12 gives us negative 144. Look at our like terms. Our like terms in the middle. One's a plus, one's a minus. They're the exact same number, exact same letter. Well, those are just opposites, and when you add opposites, you're going to end up with 0. So that means we just end up with y squared minus 144. The neat thing about a difference of squares is it only has two terms. And both of these terms are squares, which means we can square root them. In fact, look what happens when you square root these two things. 144, the square root of 144 is 12. The square root of y squared would mean what times itself gives us y squared. The answer is y. Look, y. A difference of squares is two terms that you can square root with a minus sign in the middle. This is going to become important when we do factoring. Let's try one more to show you that we end up with a difference of squares. We have the same terms, but with opposite signs. 5c times 5c is 25c squared. 5c times negative 4d is negative 20. And we've got c and d, so cd. 4 times 5 is 20. D times c, write them in alphabetic order, we got cd. Last terms, 4d times negative 4d is negative 16d squared. The two terms in the middle are the exact same with opposite signs. They're going to add to 0, and we're just going to have our two terms. There we go. Difference of squares. We can square root 25c squared, and we get 5c. We can square root 16d squared and get 4d. So this is a difference of squares. And the relationship between where we started and where we got to is important because eventually you're going to be asked to go backwards. But for now, we're just expanding, and we're just foiling, and we're acknowledging that these are special cases. Why are they special? Well, because the results of expanding are unique, as we have perfect square trinomials and difference of squares. All right, that's it for part 1 of lesson 5.2, special products. In part 2, we're going to look at word problems. Thanks for watching, and I'll see you in part 2.